Okay, we're live. Um, so go ahead and open Revit 2018, and hopefully your computer doesn't give you any problem today. If it gives you, we may need to switch you with another person. Okay, and so I'm going to go over the entire script again. I'm going to go faster than the last class because I need to cover additional material. So stop me if you fall behind. Please, I don't want you to fall behind. All right, so let's go and start a new family, and let's start using the template generic model adaptive. And here we're going to launch Dynamo. It's under the Manage tab, the Dynamo tab. And I don't know what's taking that long. Okay, there it is. Okay, so we're going to start a new script. And remember, the first step to create the tower is to define the points. And the point needs to be spaced at a certain distance, and it has to have a maximum height. And so we start by creating a range. And the range is something you create inside a code block. So just double-click the white space to create a code block. And if you recall, the range has a start point, which is 0, ground level. And then in the instructions, I said that the tower needs to be 150 feet high. So the maximum height is 150 feet. And then the distance between the floors, I think it needs to be 15 feet, okay? 10 feet, okay. So I put 10. And this is going to give me a number of elevations from 0 to 150. So I will have a total of 16 items, including item 0. Then I will create a new point. So to search for the point, you go right-click, and in the search tool, just type point by coordinates. And this is going to create a default point in the background. You can see the point generated there because this is preloaded. And then I'm going to plug the code block to the C elevation. And if I switch to the background and zoom extent, this is the zoom extent. You see that now I have 15 points. And each of the points is going to define a floor plate. Control V. Control V takes you to is that what you asked? And then if you click again, Control V, it takes you back. Okay, so each of the points may host a different geometry. And so it's a good idea to define each of the points as a coordinate system. So I'm going to associate for each point a work plane. And the work plane is going to host some type of geometry. So we need to create a plane, right? And so a plane is a command, it's a node. And if you just search for plane, you're going to see all the different methods of creating planes. but the node that is called by origin and normal, that is the one I want. Plane by origin and normal. Origin is the point. We're going to plug the points here. And the normal is a vector. Because the plane could be in that point, but it could be in any direction. Right? But I want the point pointing upwards. And so I need to define what vector or what direction that is, which is the z direction. And so we need to find the z-axis. And in there, just search for ZA. And the very first item, you're going to see the z-axis. And so I'm going to plug the z-axis into the normal and the points into the origin. Now, for every point, I have a plane. You see that? And Dynamo even have a graphical representation of what the normal is, what's the direction. Excuse me here. Okay. So, Kaz asked me, well, what can I do to have different geometries in different elevations? So last class we created a single extrusion across every geometry. This time we're going to create a loft between 3 ellipses of different size. So the logic behind this is as follows. I'm going to have one ellipse at the bottom. Then I'm going to have another ellipse at the middle and another ellipse at the top. And so these ellipses, each of them is going to have a different size. And so in these planes, this is a list of all the planes processed by the node. In this plane, I need the ability to pick the very first plane, the last plane, and then the plane in the middle. And the way to do that is by selecting elements by index. If you recall, this little number that is under shadow, that is the index of a list. And it itemizes every item in a sequential order. So the node that enabled me to do that is called get item at index. So if you right click and search get item, the very first one, it says get item at index. And in here, I can create a small little list. And to create a list, you just do, remember how to create a list? It's index in curly brackets. So in curly brackets, I say, I need the first item. And the first item, what index it is? 0. And then I need something in the middle. And I don't know what the middle is. It could be 7, it could be 8. But if I want to do this parametrically, it's going to be the total count divided by 2, right? It's going to be 8. But I'm going to make it parametrically. So I'm going to, after 0, I'm going to declare this as a variable. I'm going to call it half. It's a variable. And then the last item, one of the things about lists is that I could pick an element by negative numbers. So item 0 is my very first one, but item -1 is going to be the very last one. You know what I mean? So 0 is first, and then I go to 16. But if I do -1 equals 16. It's like a reverse. Like a reverse order. That's a good question. What if it wasn't 15, but it wasn't 16, but it's 15, it will be 7.5. Right, so we're going to take care of that. I'm going to do -1. And just to test that it works, you don't have to do this. I'm going to do this 8 here. And when I plug my list of indexes here and select it, oh, minus where it didn't work. Okay, well, this didn't work. Yes, so I'm going to take care of that too. So let's call this half, and then click comma, and then put last. So this is going to create 2 variables.
So last instead of -1.
Correct. So this is asking for 2 new inputs, the half point and the last item. Are you with me here? So to find the last item, just there is a node called last item. So if you just search last item, this is going to give me the very last item of the list. I'll move this a little bit so it's a little bit. So the last item of the list is going to be the top plane, right? Because 0 is the bottom. And then the last item I plug here. And now the half point is the count divided by 2. But you're right. If the number is not even, then I'm going to have a residual that I need to take care of. And so I need to choose. You want to pick the one at the top or the one at the bottom. And so I'm going to say I'm going to use a formula, and the formula is called round up or round up. So what I do is I open a code block, and the easy thing to do is to do count. And notice this, in Dynamo, functions are explicit nodes. They could also be design script functions. Like, for example, I don't have to add the count node. I could also use the function. But I'll go, rather than complicate this, I'll go easy with you. This is going to be C divided by 2. That's the count divided by 2, right? But then I need to be able to round this number so that I take care of any residual decimal. And so to take care of the residual, I need to declare a math function. And the math function in the code blocks, I start with the word math dot round parentheses, and then close the parentheses at the end. So whatever number is there is going to get rounded using mathematical roundup formula. So if it's 0.6, it's going to be up. If it's 0.49999, it's going to go down. Just type math dot round. C divided by 2. And got angry. Oh, because I put a curly bracket. My bad. Okay, the code block is asking what's C, and C is, what do you think? Is the total count, right? And so I right-click, search for the node called count, and this is going to give me the count of all the planes, and then I'm going to connect C in the code block. Now I got 8 even. It's always going to be an even number because of the round function. And then I'm going to plug this into the half. And there's a mistake here. This last item is giving me the last element. What I need is the last index, right? And the last index, it is going to be the count, except that the last item here, if you notice, what is the last index here? 15. But if I do count, it's going to be, so what do I do? Correct. So I do, I'm going to remove the last item, and we do a code block, and I'm going to call this C minus 1. And C is the count, which I just have here. And then I plug this into last, and I have the list I was looking for, 0, 8, and 15. And so I could technically, you don't have to do this, increase this to 200, and then the math is going to work parametrically. Now I have 0, 10, and 20. I just changed this to 200 to prove that the math, it's always selecting the middle item. Let me clean this a little bit. I don't want this to be too messy. But I'm going to leave it at 150 because that's what the homework talked about. And then in this item, I'm going to get 3 planes. Do you get this result?
My, this, that item that is yellow.
This result. 0, 0, 0. So I see. Do that. This is not working, so I'm going to. Let me do this. There's another way to do this, which is count. You have to hit run. Okay, so we have 3 planes here, right? And so in each of these planes, I'm going to draft. You can choose to draft different geometries. I'll give you options. I'm going to do an ellipse. So you go ellipse here by origin and radius. I'm going to give you this, my script. You can take it home. And then an ellipsis has 2 radiuses, the long and the short, right? And so for the long, I'm going to say this is 20 column. And for the short, for the x, I'm going to say it's 10. In the same block, I can do continuous lists. I'm going to upload this in x, another one in y, and I am also having, oh, you know, this is asking for a point. This is not the method I need. My bad. Please remove this. I need a ellipse, and you can use the right click and type ellipse. And which method do you think I need to use? Correct. By plane and radius. And so I plug planes here. I plug 20, and then I plug 10. But in reality, what I need is, this is doing it for all of them, right? Which we could do. So I'm going to put in this, you know, nodes can be grouped. If you select multiple nodes and you right click and say create a group, you have the ability to make portions of this script, organize them in a visual way. The only good thing that add a group is it's just a way to somebody else to organize. And I'm gonna add here. This is your options. You can create an ellipse. Another option you have is to create a different shape for every plane. And so one of the ways of getting items by a specific location, it's a little script called, this is a design script inside a code block. You declare any variable. I'm just going to declare x. And then in brackets, not the curly one, but the regular one, you define the index number. So in this list, I have 3 items in index 0, 1, and 2. To just pick the first item, this is the design script formula. So if I do this, then I just get the very first item. That makes sense? So if I need the last item, what's this design script? Correct. So I'm going to break them down one by one. So I'm going to do x1 and x3. Each of them is oh, there's no 3. It's 2. Sorry. I don't think so. And so by doing that, each of these ports, I have the ability to just select one of those items. And so I'm going to disconnect the plane so that I'm just going to leave that there as an option. If you want to do that, just do use this. I'm going to do it this time. I'm going to do a circle. And I'm going to say that the center, I'm going to have sorry, I'm picking the wrong one. It's circle by plane. So this circle by plane and radius. and I'll say that the radius at the center is 10 feet. Now I only have one single circle in the middle of the element. Notice how the ellipse still remains in the bottom. What do you think? Why? Some nodes comes preloaded with default values. And so if you hover over plane, notice how the default value is the origin of the coordinate system. So by default, it generates one. So I'm gonna leave it there. And then at the very top, let's do another ellipse. So you can just this option that you have here. If you select the whole group, you can Control C, Control V. And I'm going to select the top, and the top point is X2, right? This is the plane. So now I have a circle and two spheres. I'll give you other options. Things you can do is you can create multiple circles and then create a polygon. Regular polygons. Regular polygons need circles. Yeah, select the group, Control C, Control V. Or another way to do this is select the group, Control drag. It's the same. Okay, I'm going to put this as an option. You can, inside the circles, you can have a number of sides. So you can say this, rather than have a circle, I want a polygon. If you need by default, the polygon comes with a value of 5. You can say make this 4. Now I have another value there. And you can choose to have the top as a different regular polygon, the bottom as a different polygon, or the middle as something else. It's your choice. So I'm going to right click here and say this is your option. You pick and choose. Okay, in my case, I'm going to stay with the 3 ellipses, with the 2 ellipses and a circle. So now I need to do, if I want this to do parametrically, then I could replace the radius with an integer slider. So if you right click and look for integer slider, this is a way to change. I'm going to plug the radius of I'm going to make the radius parametrical. And when you're doing this at home, find opportunities to make this parametrical. So if you want their axis to be parametrically, you don't have to use the code block. You can replace it with a slider and have much wider range of results. Remember, if you present me an elevation with like 3-4 different options and do screenshots, that's a bonus. So if you can make this parametric with sliders, that'll give you a larger degree of possibility. Okay, so if I do this, then the slider is going to increase the middle, and I can make it bigger, make it smaller. And then you can pick and choose the shape that you like the most. Okay. I have 3 shapes, and that's all I need to create the loft. A loft is the surface between the 3 profiles. What you do is right-click and look for loft, and this is the very first choice, loft by cross sections. And in this, I need the 3 profiles. So I need a way to combine my top ellipse, my bottom ellipse, and the circle in the middle. You remember that node to create a list? You go right click and you say list create. List.create. And the list.create, it's I have the ability to add additional ports. So how many ports do I need? 3. So I click this 2 times. And it's important that loft have the right sequence. I need to start with the bottom, middle, and top. If I mix them up, it's going to fail because the loft needs to be directional. Or I can do top, middle, bottom. But I cannot have middle, top, bottom. It's going to fail. So my first item, I'm going to pick the bottom one. The bottom ellipse goes at the bottom. The circle goes in the middle. The ellipse goes at the top. And I have a list of 3 shapes. Again, at home, you have the options to do polygons of different sizes. And you can make them parametrical with sliders if you decide to. And then I connect this list of objects into the cross section of the surface by loft. And there is my shape. Again, you know, the middle one is the one that grows. So I could just increase the size, and you know, it becomes now a barrel. Or I can make it slimmer and make it elegant. I don't know. You decide. And then the ellipse as well could be can be made parametrically. I mean, both sizes. For example, I'll show you one way of scale it all. At the top ellipse, I could say 20 by a factor. And I'm going to say 20 times, I'm just going to call F. And then the other is going to be 10 times F. F is a factor. And then I can plug a number slider. And the number slider, it's a value that will multiply the 20 and 10. And then when I increase it, it becomes like really big or it becomes really small. It cannot be 0 because then the loft doesn't work anymore. So that is a way to scale the geometry. Another question? This by default is coming at the bottom. You can also scale the middle if you want to, or the bottom one. I'll give you that freedom. Just if I need this to be more granular, you can say, okay, the minimum is 0, the maximum factor is 30, and I'm going to step it out 0.01. And what this is going to do is give you a greater, it's not going to be too drastic. Like you can limit, you can increase the steps. You good over there, Cass? All right, next goes the twist. And so the twist can happen you can pick one of the elements to rotate. You can pick all of them to have a different rotations if you want. Like I can pick the bottom profile to have a rotation, or the top one to have a rotation. In my example, I'm just going to have the top be a rotation, but you can choose. So the top ellipse is right here, right? When you select this, it highlights in the background. And so the rotate, it's in Dynamo is not called rotate. And I don't know why rotate is not rotate. Actually, it is. But move is not move. Move is called transform. Transform. Like if I want to move something, I use the transform node. But in this case, if I need to just rotate that geometry, yeah, look for the rotate geometry. And yeah, there are different ones. I'm going to pick the rotate, origin, axis, and degrees. Or actually, you know, it's easier if I do the other one. Rotate, base plan, and degrees. It has less inputs, and it's actually asking for a work plane, which I already have. So I'm going to delete the geometry rotate, and I have my base plane here. So in the geometry goes the ellipse, right? The base plane is the top work plane, and where that is, if you remember, here is my list of planes, and it's the very last one. Is this guy. So I'm gonna connect the last plane right here, and the degrees is a number. Now degrees are from 0 to 360, right? And if you want to do this parametrically, let's do an integer slider. The integer slider goes by default from 0 to 100. If I want this to have a full complete circle, I will change the minimum and the maximum. So in the drop-down list, I start at 0. I'll finish at 360. And you can say, you know, what's the interval? Maybe I want to rotate every 5 degrees. I want to change this to 5 degrees. You decided. Again, I'm just making decisions as we go as far what's the minimum and the maximum. If you want this to go multiple turns, then you can increase this to 400, 700. But I don't think you have to go beyond one turn. All right, so I'm going to plug this into the degrees. And then I'm going to replace this geometry is the rotated ellipse. I'm going to replace in this list of elements, I'm going to replace the top item. I'm going to replace my item 2. I'm going to plug the geometry into item 2. Why? Because I don't want to use that geometry anymore. I want to use the rotated element. And so you can see now how as I move the slider, now the tower is twisting at the top. Right? And then it can go up 360 degrees. You can choose to rotate also the bottom part. Why don't we do this? Why don't I let you do this on your own? Try to pick the bottom ellipse and give it a rotation, plug it in the list, and have the surface rotate. I'm going to do it at the end. You can do it. So you answered earlier how to do that. Now you have like this. Number counts. Number counts. I like integers, and I don't want to use decimal. Because decimal sometimes goes to where I have like 9 digits, and sometimes I'm wanting to have all the like decimal. Yeah, that's okay. The only thing, so this is the rectangle. So basically this guy now scale factor of the Okay. Think about the proportion, right? At the end, you want to have a tower that kind of looks okay. You want to have something that is uniform. Okay, so now I need to take care about the floors. So here I have a shape that spans 150 degrees. But I also need to I need to create some. I need the ability to create the outline of the slabs, right? And I don't have slabs here right now. So the easy way to do this is to find the intersection of the surface with each plane. That's going to give me the outline of a floor. So I want to wait for. And so the let me give you also other options you can try. We talk about circles, we talk about ellipses, and we talk about regular polygons. If you go to the geometry under Revit, I'm trying to see what else we could do. You could try building a building that is an helix. An helix is going to be, you know what an helix is, right? And this helix could be the center of a, you can make it, or you can make two towers that actually do like, they intertwine each other. If the helix could be the axis of extrusion, right? And then the profile just move all around. Again, just giving you ideas. Okay, so we were saying that we need to find now the boundaries of the slabs. And we're going to do this by finding the intersection of every plane with the surface. So look for the node that is called intersection or intersect. It's called intersect geometry. Geometry dot intersect. And so this is looking for two inputs, a surface and everything else. So the surface is coming out here. And I'll tell you something. This surface in the surfaces in Dynamo sometimes cannot be directly imported into Revit because Revit is a little bit limited in the computation of very complex deformations. And so one of the ways to solve that is to make the surface become a nerve surface. Are you familiar with that term, nerve surface? It's very typical in Rhino or in nerve surfaces. And so there's a node that converts a Dynamo surface into a Dynamo nerve surface. And you call it nerve surface. Or you can just search, you can search surface dot to nerve surface. surface dot to NURBS surface. And all this is doing is just make it easier for the Revit translation. And I'm going to plug the surface and convert it into a NURBS surface. And then I'm going to intersect the NURBS surface with what?
The plane.
So it's the whole list of planes, right? So I'll just go, I plug the NURBS surface into the geometry, and then I plug my planes. So go back and find the list of planes, which is at the very beginning. It's this one, plane by origin normal. These are my list of 16 planes. I'm going to plug all the way from here. And when you have these long distances, you can press the mouse wheel to pan over on a side. I'm going to pan over and hit other. And now you see the outline of the slabs. Again, I'm picking it all from the plane by origins, the 16 planes, and I'm plugging it all the way to the geometry intersect. And then this gives me the intersection for every level.
And my geometry are there, you can see them flapping around.
Yeah.
But they're there.
Yeah, okay. You want to reduce the topic of home? You can go to the slider and scale. Make it, did it work? I think you know what's happening is I have two surfaces on top of each other. Remember, Revit, Dynamo keep remembering a sequence of events. So you can hide the surface by loft. You can just freeze it. If you right click on the node and hit freeze, that's going to switch off the two surfaces. And now I think I'm just only left with it. Oh, my bad. Undo. It's not freeze. It's hide in view. Is the preview. Disable the preview. Now it looks probably cleaner. That probably works for you too. Yeah, just with left. You guys use, instead of a circle, use this, right? So the nerve surface, you don't like the, it looks like it's having a hard time processing the map. Oh, wait a second. Oh, okay, there. Let me see. Change this. Yeah, for if you went that route, ignore the nerve surface. That's what it is. You skip the nerve surface? Yeah. Yeah.
But am I able to
Preview. Yep.
can
Yeah,
I
I think so.
convert it to Revit?
Yeah. Cool. You good? You good? Good, good.
If I put preview, that's what ours have.
Yeah, that's exactly the same thing that was happening today. So what we were doing is we need to skip the nerve surface and just plug it directly. Yeah. And the reason is that when we're using just circles, it's best to use nerve surface. If you have polygons involved, ignore the nerve surface.
So should it this in here or should I?
You can delete it. But if you want to keep it there, if you change your mind.
I think I'm gonna use polygons for my pipes.
It's gonna be easier or better.
Polygons.
The more complex the surfaces is more poly in the processing power.
Not as
Okay, guys. So in this process, you can do screenshots, right? And if you present me with 2 or 3 different options that are parametric, and the way to do screenshots, you use the Windows tooltip, right? Just do it. Have you used that before?
snipping tool, right?
Snipping tool, correct?
Just make a screenshot of what you have.
Yeah, like I asked to have percent like elevation options, and if you move the slider 3 times, you have 3 options there, and then do screenshot for each of them, save them as images, and you can Photoshop to clean them up, and I'll show you how to add them in Revit. Okay, so nothing's happening in Revit yet, right? Now I need to rationalize the surface so that it accommodates points that will host adaptive components. And so we will use the next node we're going to use is from Lunchbox. I think it's called Panel Quad. Panel Quad. So Panel Quad, what it does is create square panels on a surface based on the U and V subdivisions. The U subdivisions are the number of divisions in the X direction, and the V are the vertical, like in the vertical and the horizontal. And here you decide again how many subdivisions you want. But for my example here on screen, I know I have 15 floors, right? And I can say, okay, 15, maybe I do 2 panels per floor. So that's going to be 30 horizontal, and I'm going to do 30 in the U. If you want to do this parametrically, then you need to grab the count of floors and multiply it by 2. That's another option. You can do C times 2. And then V is how many lines from bottom to top you want. I don't know, I'm going to say 20. And then I'm going to plug the surface to the panel quads. And it didn't like it. Yeah. And the reason it didn't like it is because if you examine the geometry intersect, these are the nerve curves. I'm actually looking for the surface. And the surface, it should be this surface coming out of the loft. I'm going to use the nerve surface because I'm using curves. But all of you, I think, are using polygons. polygon lines. So this is the surface.
So what are we going to do? This is like
The surface is going to get subdivided. Is that the more subdivisions, the longer it takes to process.
so I can swap into surface.
Correct.
I mean,
Did it work for you guys?
it's
A single, it just created a single.
This it has to do with the polygon Dynamo that this guy is inserted because this is different from the top.
Let's try another one. Let's try, let me think about it. Panel.
Yeah, if I use circle for the middle part, it works. But not really.
Because I have a circle and two ellipses, and it works. But I'm using the nerve surfaces.
And maybe when we have actually two ellipses on the top and then one circle at the middle, we use polygon and then change it to circle, but then we have something over here. I don't know.
I want to see if there's another node that can help. Seems like it doesn't like it. We're breaking the. If you guys close it, save it, and then close it and run it again. See if it works. Because it looks like this. Is having a hard time using ellipses, and the my guess is the surface resultant between the ellipse and the polygon is very irrational. Like it will be very. But let me try that. I'm gonna replace the polygon. Regular. I'm going to do this circle here. That it's far. And then I'm going to close this. to the second item. The other thing, moving forward, change the processing from automatic to manual. Just because as we progress in the development of the, I'm having the same issue, you see. It seems like that it's only picking one side of the polygon instead of. Oh, that's because I have 30 and 10 in the UV. Do you have it too? Circles work. Oh, I have to use. I see there are two surfaces here. That's the high one and the other. You have it. Yeah, it's just that. So this is, if you look at this is golden panel. Each panel is this middle. And so that overlaps with this next surface. That's why you see kind of that. So I guess this is a limitation of I don't know how to work this out other than if you can make it a circle rather than a polygon. So instead of using this as a polygon, I use it as a circle. So you can just plug this in the second line. So the circle, this is the polygon, right? So you can just plug this circle into the list of items. The second item. It's the item one. So let's do this. For the assignment, just use either circles and ellipses or polygons. I think if you use just polygons, you might not have that problem. Like if you
But
go,
I used ellipses, polygons, and
yeah,
not polygons, in circle.
the surface works, but the subdivision is not working. Like that kind of quad is not working very well, and I don't have a suggestion for you. So we need to rationalize the surface. Okay, so. So are you somewhat like this or similar to this?
Doesn't show the ribs. I mean, I can see silhouettes of it, but it doesn't show.
I think it
shows.
Yeah, it shows. You can hide the surface. So if you switch off the preview of the surface by loft, and the other things, and this is the panel. That's it.
Freeze.
Yep. You can switch this off. Very good. Okay. So if you notice, nothing has happened yet in Revit. As you develop this, try to organize it. I know we're going very quick, but all the script, what it's doing is creating the surface, right? And so this is creating the planes, and then from the planes, you can basically select all of this, and this is the surface creation. Create a new group. Oh, I cannot have groups inside groups, but in reality, if I was doing this organized, I would select all of this and say, this whole part of the script is just taking care of the surface. Yeah, you can do it in Photoshop. Right. Like if I select this and then right click, it doesn't. Add to group. Yeah, but you see that it disappeared. One group disappeared. I had one group here. I used to have 3. So all it did is expand an existing group. But I cannot have groups inside groups. Yeah, it's you can change the color if you right click and say and so different portions of the, you can do this in your finals. You can say this is and you can use one of these pastels too. Correct. Yeah, if you guys want to, I mean, we can start. Let's say, I don't know, 7:30 while you print. You can have an hour. Okay. If you can bring it printed, that will be better. If you cannot print it, I can give you time to print it. And maybe in the last class, what I want to do is each of you explain again the process and where did you hit a wall. Like right now, we hit a wall with this inability to swipe. I'm going to try to spend some time between now and Monday, see how I can solve that problem, or if I can have another solution for you, and I can email you back.
Do you need my file?
No. I think I know what the problem is. Okay, so out of this, I have panels. You see how I have 3,000 panels, and I have points, and the points is groups of 4 points. And remember when we were looking at adaptive points, we were actually we needed 4 points that snaps to different points, and that's exactly what we're going to do. We're going to create a. Let's save this before it crashes. So save as, and I want to put it in my desktop. And let's call this Twisting Tower. All right, so I'm going to leave this a little bit on the side, and now I'm going to focus. You see, nothing is going to happen in Revit until I bake this with an adaptive component. Oh, let's do something. Let's do the floors. So we have the contours for the slabs, but they are actually at the surface, right? And maybe we need to scale this by a little bit so that they are inside the surface and they don't overlap the Revit geometry. And so what I need to do is find all of the outlines, which is these guys. If you look at this, I have 16 nerve curves. And notice how this list is a list of lists. It's not a simple list. And one way to simplify the list is using the flatten node. If you right click and just search for flatten, this make that list a much simpler list. Flatten. No. And so now that I have this flat list, I'm going to scale it. And so to scale it, if you look for the node scale geometry, or right click, scale, there is look for the scale plane X amount and Y amount. Geometry.scale. Yeah, it's called X plane, X amount, Y amount. No, this one. Actually, you know, I think we could do, you're right, I could do this guy. Actually, and the very first one, no, this is not on a formula. Just this one. No, we don't need. And so I'm just need to scale it just a little bit. I'm just going to scale it maybe by 0.95. And I'm going to plug 95% into the X amount and to the Y amount. If Dynamo becomes lower, I think you can save. You have to close the Revit session and then open it again. But we're gonna go in a break in a bit. Maybe we do that then. Also, Sully, what you can do is rather than make this automatic, set this to manual, and then hit run every time you want to run the. Because if you do it automatic, it's running every time. Okay, so if I want to scale the contours of the slab, where are they? It's in the geometry intersect, right? It's this flatten. So I'm just gonna flatten here, and then hit run. Because Z is gonna X and Y. Yep. So we don't. It doesn't have anything in Z. And if you want to start cleaning this out, the only thing you really want to see at this point is the slabs and yeah, like I'm actually going to select everything in the script except the panels, and I'm going to hide the preview. This is kind of messy. Now, if you see this, you can see that now the slabs are right inside the surface. And they're not overlapping with the outside surface. So what I did is, again, I select everything except the panel quads and the geometry scale so that it looks better in the screen. Okay, everybody with me? All right, now that I have this, I have these labs. Let's temporarily hide the panel quads. So switch off the preview, and each of these needs to become into a floor. And the easiest way to do this is using a node called thicken. So if you right click and look for thicken, you're going to see that there are two other. There's one that is thickened, just thicken, and another one that is thicken both sides. The first one, what it does is create a surface, and then the surface is extruded by the distance, right? But if I want to preserve the top of the floor, and I just want to extrude it up, then I need the both sides. And say both sides no. That means you're just going to pick one side.
Well, like for if I choose like this, I cannot define the direction.
The direction is based on the surface normal.
Right, but why can I just thicken? I give it a thickness so I can have the floor thickness. So I don't need to click both to tell them that which side. Just give it a thickness.
Yeah, but there's no such there's not a node that only have one input. I mean, this one is asking for a surface, and the thickness is how much. This is the value, and the surface it's and notice I still need to convert the geometry into circles, into surfaces, right? So I think the node for this is called patch. And there's a create a surface by patch. A patch is a polyline that is closed. So this could be a polygon. It could be a sequence of curves that are connected from the endpoint. And so it needs a closed curve. I'm going to run it. This is the surface. If I do thicken by thickness, this is what I was trying to explain. The thickness, it's two directional. It's from the line in two directions, both sides. And if I don't want that, usually what this means is that I need this to grow in a single direction. I don't want it to grow in two directions. So I'm going to use the other one. Right click and search for thicken. Surface.thicken, both sides. And then I plug the surface with the surface. The thickness is how much is the thickness of the slab. A typical slab is about 6 inches. So in a code block, just type 6, actually 0.5. And then both sides, I'm going to set this to false because I don't want this to grow in two directions. I just want it to grow in one direction. So the Boolean, the true false Boolean. Yeah. look for the node that is called Boolean and set this to false. So if you hover over, anytime you see a port that is asking for a Boolean, you need to add the Boolean true false. I'm going to set this to false and then run it. And now these surfaces have now a thickness, if you can see.
You connected the Boolean to
Yeah,
both sides?
and set it to false. And this creates, a list of solids. For every floor, there's a solid. And so in
I use like the thickness one without both sides. It created the same syntax, like
the difference is that is the both sides. So if this is to true, look at the difference. It's very subtle. You see how the structure happened? Like this is from the center of the polygon is at the center of the slab. But if I do this to false and run it again, the extrusion goes from the bottom up.
But what if you don't do the both sides, just the thickness, it will be at the center?
And whether you do it this way or the other, I'm not gonna. I really don't. It's not important. You guys with me? You with me? Okay, so time to bake this.
But mine's still separate.
Did you set this to false?
Yeah.
Did you hit run? Okay, baking to Revit, it's really tolling process in Revit resources, and there isn't really a very clean way of doing it, and that's probably where Dynamo, it's compared to Grasshopper, it's a little low because it takes so much time to process. One of the best nodes to move Dynamo geometry into Revit, it's in the Springs node. So we installed this package last time. Do you still have the Springs? Okay, so if you go to Springs Revit, you're gonna see under the form, there is a Springs form by geometry. And what this is going to do is create a Revit geometry from anything you plug there. And I want this to become slabs in Revit, so move the solids into the geometry. Before you plug it, make sure you switch this to manual, right? And save. Because, well, if it crashes, I don't know if you have saved, but if you plug it and run it, then it's gonna take, I don't know, 30 seconds. Oh, it was fast on my machine. And there they are. And so in your assignment, you can switch to a front elevation and do a screen capture of the floors. Or you can keep it in perspective. One way is to improve the visibility. Remember the graphic display options in the background. You can make, rather than make the gradient, you can make it none and it's going to be completely white. And if I switch this to shaded and do an elevation, you can do screen capture of like that.
Set up over levels and stuff manually.
We're not going to do levels because we are baking in the family editor. Unless you want to do the levels.
design it so you have it, so you will have growth plans based on this graph. This will explain it as a line, a model in the Revit.
Yeah.
It's not for model.
Uh,
Can I like make changes to the growth that I have right now?
yep. Like if I decided, oh, anything, like I can decide to increase the size. I'm gonna like do the rotation. I'm gonna increase the rotation here. And again, I need to put a new value, run it, and again, it's gonna take some time because it needs to recreate. Actually, did it very quick.
But you mean like no matter what you want to like change, it has to be done by Dynamo.
It needs to be done by Dynamo first, and then it's baked into Revit.
But this is the family cover. Are you going to like load it into the project?
Yes.
Why not have
The blue lines is the preview. So if you go to okay. You good? You create your flags. Beautiful. Again, you can create a couple of screenshots with different shapes of the slabs. You can hide this in the background if you don't like this. Right-click hide. Okay, so this takes care of the slabs. And so all I'm going to do here is, you can select this 6 nodes and make a group out of that. Right-click, create a group, and you can call it here floor slab creation. Okay, so let's have a 10-minute break. It's 8:40, but let's be back at 8:50 exactly because we still have a lot of material to cover. So save your file. Maybe the good idea is close everything so that we release the cache memory from the graphic card. You don't have to save not anything. So you don't have to save. Because if you start again with a fresh file and run this script again, it's going to be so one way of doing it is a feasibility graphic. You can say, oh, it's you go here, graphic, play options. You went, you can change the color if you want to. And then you have to reallocate the camera. I want to pause in the recording. Yeah, these are conflicts in the operation between the custom packages and like all these packages that are created by users. They use Python and C Sharp and Visual Studio, and some of these conflict between each other. And so when let's say the Spring nodes is in conflict with Lunchbox, um, there's a competing uh, code going against it, and this is just reporting that, like, if you click display all, you see their dependency conflict and becomes unstable. You click details, it tells you, what is the conflict about. So
it's not doing like for the project itself.
no, I mean it makes the software a little bit unstable, and it might be more susceptible for crashing, but we just live with it. Okay, so we have our slabs, and then we were able to bake them into Revit, right? And then I mentioned that you can create several snapshots. You can add shadows if you want. Although I don't think you can add shadows in here without a sun. I don't think in the family environment you can do that. If we load this into a project, then inside the project, you can add shadows. We don't have a project yet. We're going to do that at the end. Okay, so we've finished the floors. Let's display the panels again, display the preview. You're going to get the grid in the background. And now we need to convert each of these panels into a fenestration representation using adapted points. So what we're going to do now is we're going to create adapted components of 4 points with an opening. And then we're going to try to make the opening respond to a tractor point. And what that means is that the size of the opening will change depending on this how close they are from that point. And so in that way you can have a cool tower with different opening sizes. Okay, and so I need to create a new family. I just want to show what we expect to do. Is this? Did I save it? Let's close this. Review. Yeah, here. This is what we're going to do. I'm just going to show you, and then we're going to do it from scratch. So this is a 4-point adapted component, and then there is a chain of lines connected around, and then there are 2 diagonals. Each of these lines is made invisible so that it doesn't show in Revit. You can make it show if you want. And then these diagonals have a point, and the placement of the point is driven by the normalized curve, which is associated with a factor. Remember what this is? This means that the point is located at a quarter of the length of the total size, the total length of the line from the beginning. And so I do that 4 sides. And then this is a nested component. This is another 4 adaptive component that associates with the 4 points in the model. And so the beauty of this is that I can change this factor. So see if I change this to 0.125, apply it. I think it becomes narrower. Or I can make it 0.45. And it's going to make it really bold. Weird that, oh, because I have, this is all separated, right? Can this be 0.6? What do you think? No. So the maximum, the limit is 0.5. Actually, it cannot be 0.5. Oh, let's try it. I think it's going to fail. Yeah. But if I do 0.49, or 0.45, or 49, yeah, it works. There's going to be a really tiny opening in there. And so what I'm going to bring this adaptive component into the project, into the another family. And then I'm going to use an attractor to define a distance. I mean, the relative opening is going to have a minimum and a maximum. I need to define that. The minimum is going to be 0.1. The maximum is going to be 0.45. And so the closer it gets to the point, the opening is bigger. The farther from it, it's going to get smaller. All right, so we're going to build this from scratch. So let's start with the nested component. So let's start a new family. And we're going to use the generic model adaptive. And if you go to the top floor, it's probably a good way to do that. Let's add 4 points in a sequence. And it's best to do this clockwise. So you go point 1, 2, 3, and 4. Escape, escape. Now I'm going to select the 4 points, and I'm going to convert it into adapted points. Adapted. Make sure that the sequence is correct. 1, 2, 3, 4. And then I'm going to join them with reference lines. The reference lines is the second icon from the draw panel. And I'm going to use 3D snapping, so that snaps to the point. And I'm going to go from point to point. Make sure that you see that symbol of point, that snapping point. 1 to 2, 3, 4, 5. Escape, escape. And I should have a closed loop of reference line. They need to be green color. You with me? All right, so I'm now going to convert this into a surface. And to create a surface, you select the chain of lines and then create a form. And make a surface. And that is a surface, right? And you can give it a material. Remember how to create materials? I'm not going to go over that because we covered that already. But if you want to create a new material, you duplicate the default, and you open an asset. No, there's duplicate, rename, duplicate the appearance, right? Then you go into the browser, go to the appearance library, select any material. You can make any paint, for example, if you like pink. Add it to the asset, and then that material is going to travel into the family. So I'll let you pick a material. You remember how to do this, right? We did this in a previous class. Okay, I'm going to leave it neutral here. Save this file as, I'm going to call it solid panel. Solid panel underscore AP, which is adaptive point component. Solid panel AP. I'm going to put it on the desktop so I can remember. Okay, you can close this file. Let's go ahead and create again another family, new family. And this is going to be a generic model adaptive again. And again, in the top floor, in the top view, let's create 4 points. 1, 2, 3, 4 in the right sequence. Make sure it's clockwise. And select those 4 points and make them an adaptive points. It's just the point command here. And then I'll select all the points and make them adaptive. Double check that the sequence is correct, because this is the sequence that the lunchbox panel points are made of. And again, I'm going to select point 2 and point 4. You can do control and hit point SP line through point, which is the third icon from the top, from the lower left side in the Go panel. And let's pick point 1 and point 3. And again, draw SP line through points. They're going to create a straight line. They create a next. You can choose to leave it if you want it. I leave it up to you. If you don't want to see this traveling or not to be visible in the project, select the both lines and click this checkbox that is visible. What this do is when I load this into another family, those lines are not going to be visible. They are not going to travel. So I'm going to disable that for both lines. They tone down as you do. You with me? Okay, now we're going to create 4 points hosted by the line. So again, point number 1, point number 2, point number 3, point number 4. Make sure that it highlights and snaps to the line. Now each of the points, you can define the relative location using the normalized curve, right? The normalized curve is a ratio that indicates the relative position of the point from either the beginning or the end of a line. And then these values can be converted into an instance parameter. In fact, it has to be instance because every panel is going to have a separate value. So go ahead and click the associate button next to the value cell and click add to create a new parameter. And this is the ratio, so I'm going to call it R. I'm just going to call it R, the ratio. And it's going to be instance, right? Click OK. And as a placeholder, I'm going to make the value be 0.25. You with me? So were you able to create a parameter R, and it needs to say the default. Default means it's an instance parameter. All right, so now pick the rest of the points. I'm going to pick my point number 2, and I'm going to change again the normalized curve. I'm going to connect it to R so they all have the same value. Just click this little switch and associate with R. Okay, so it all depends on how the line is created. So for example, I created my line from 1 to 3. So this is the beginning, this is the end. If your point flips, what you need to do is the following. Look at this, look at my point number 3. I'm going to switch the measure from the beginning to the end. You see? And then I'm going to connect it to the R. Again, you select the point, and if the value is like 0.8 or 0.7, that means it's in the opposite side. So you need to measure from the end and then associate the value with the parameter R. Does that make sense? Yeah, so why it happens, I have no idea. So this will be the other point. So if you're doing this at home and it happens that when you place the point, you cannot find the normalized curve, even though it's snapped to the line, save everything, close Revit, and open it up. This is a Revit glitch. Yeah. We'll put you next to you. It's supposed to be fast. this time. If you associate the points with the point 25, so that's a point. How do you do it? Oh, you use it as line. Smart. Okay, got it. So, go here. It shows you So to test the family, let's flex it. Open the type properties and then change this to 0.1. You change the parameter to 0.1. All the points need to get closer to the adapted points. And if you change this to 0.4, it needs to get closer to the intersection. That work? Okay. Let's leave it to 0.25. All right, so now I'm going. You have a question? Now I'm going to bring the nested family. So the one we saved before. So go to Insert, Load Family, and go to the desktop or wherever you saved the solid panel AP. And it's loaded under generic annotations. You will see the category family type. If you select the type, then you can start placing it. I recommend that you place it again in the same order of creation, 0.1, 2, 3, 4, 0.1, 2, 3, 4. So if you drag and drop the type, you can start snapping. 0.1, 2, 3, 4. Then 0.1, 2, 3, 4. And then flex it. difference between when we came here, I would say
Change it to I don't know. Somebody.
it's ellipses, yeah.
Since you changed the view,
Let me see how it works in 3D.
yeah, it's just a point, I guess.
Um,
Thank you so much.
do the same.
So it doesn't matter the
The direction, the only way it matters is because is the direction of the normal. Like if you place it clockwise, the normal is pointing up. If you put it counterclockwise, the normal is pointing out. And when you render, you might have an issue, but I think it's best to put it clockwise. It work? Can you flex it? Flex it here. So it didn't work. It didn't snap correctly. So you have to delete it again and make sure that snaps to the point. Like when you drag and drop, wait, look for the floor plan again. Like you see that there's a point. You see there's it has to say point. Yeah. And then, yeah, that's the last one. Is Google over there? Yeah. That's nice. Go to the 3D. I would say please ref. So, did you flex it and it work?
where do I oh, let's see. Sorry.
2.4. Are you good there?
Should we leave it in a
Yeah, 0.25. Okay. If you ideas, if you want to go a little bit more advanced about this whole thing, rather than being a plane, it could have a thickness. Like you can make it have a thickness. And you can also make it like you can make it a circle instead of a square. Like the intersection of the two lines could be a point. Then in the point you put a circle. So
is that for like what is this
so this
related
is
to the tower?
yeah, this is the window, one of the windows. And then this is gonna snap with every panel. You see how it works? It's like floating. So it's when Revit fails, they usually I think that is going to start. Oh. you see the point? Oh, the point is okay. So the other thing is that so when you place it, you see what I did? When you place it, make it a face. That's the other thing. You know, when you place it, rather workplace, place on face. That's going to snap to the point. Okay, I'll give you other examples while you finish. Let me see. If you go to YouTube and then you search panels, Revit panels, adaptive components. There's tons of examples of how to do adaptive components. Like this will be super fancy. You see, it's super fancy. Like it will be a lot. Again, if you want to go to that extent, I'm not asking it, just if in case you're curious. There's one that's pretty cool. Like this one is pretty cool. And it show you what it is. And to start something like this, you start with a generic model curtain pattern, and then you have the ability to create this type of things. But again, up to you.
So you can put the whole thing in each surface of that.
In each panel. Yeah. Okay, so we're good with this for now, and so you go load it, save this family, save as. I'm going to put it in the desktop, and I'm going to call this window unit underscore AP, which is adapted points. And I'm going to close this. All right, I'm going to close also my family. I'm not going to save it. Now you all have saved the script, right? So go ahead and start again a new family of the adapted component type, generic model adaptive. Click open. Open the script, the twisting tower, and run it again. Run it. Nothing happening in Revit until I load the adaptive component. Oh, I'm supposed to have the floors baked. Did I not have that? Yeah, I think I have to close my twisting tower, open it again, and run it. And in Revit, I should have my slabs in a little bit. Okay, do you have the slabs? You have it? Is it bacon? Okay, so getting close to the end. Now I need to, in the tower family, load the adaptive component. So you go Insert, Load Family, go to the wherever you save the adaptive, the window unit AP, load it. And the family should be loaded there. It's called window unit AP. Notice how the nested also get loaded automatically. So we're not going to use that. We're going to use the window AP. Okay. So we have in Dynamo the panel quads, and we have the points. And if you watch the points, there's a node called watch. Watch, all it does is to display what's inside an output. If I run this, you're going to see that what's coming out of the point output, it's a series of 4 points. So for every panel, I have the vertices. And that's exactly what I need to place the adaptive component. And the next node, if you search it, right-click search, look for adaptive component by points. So again, make sure you have this in manual. You want to run it manually at this point because it's a heavy process. And in here, if you go to the family type is I need an input about the loaded families in the project. So the node here is family type. Family types. And what this brings into the project is a node with a drop-down list. And this drop-down list, if you click on it, it's all the components loaded in my family. And that includes the Windows AP. So select Window AP. That is the family that I'm going to place. So you connect family type into family type. And the points are coming out of the panel quad. So the output points connected to the points. The watch is just to watch it. It's preview, yeah. It's exactly the same you see in the drop-down list here. It's just a way to... And save it. Let's save it first. And try to do this at home as well. Save before you hit a heavy activity. All right, so as soon as I hit run, I'm going to start see Revit create the adaptive component in the background. That's going to be maybe 30 seconds. I don't know.
Did you load the surface into the Revit?
No, I don't have to. No, because all I'm creating is the adaptive points. And again, the more subdivisions you have, the longer it's going to take, but probably to look cooler. let's see if we finish first. Other but it's not what's supposed to be. So I think if you open the family, you see how it goes. It's not pulling this up. I think this has not snapped exactly to the top. So what we need to do is remove it. What we need to do is make delete it and place it again so that it snaps to the top. So the way to go is that this is not snapping because it's still the workflow. If you take this to place, it will snap. And then it has to be do this with the other okay, mine finish, and there it goes. Mine is like a little tower again. And this, if I change this to shaded, now it gives a what? You can change this to shaded. Yeah, this is flat. These are having thickness, but at home you may want to change the.
So we cannot do Dynamo with the thickness. Oh, it's not in Dynamo.
It's in the it's in the adaptive component. Yeah. It could be done, but then it's another big thing.
But we can, like for this, it's more like a window, but we can like load the.
You know the other thing you could do? You can put a glass. In the glass is going to be a 4 adaptive component with a glass material. And
Give it a thickness. It has to be with the thickness. You cannot like change the wall thickness after you.
Right, like we'll have to do it at the adaptive component.
Yeah, I see. Okay. So then now we have like extra space over here because the wall is not thick enough.
And it's okay. When we do the renders, I don't expect you to have any view from the top. Or you can exclude. You remember how we scale this? Yeah. You can exclude the last item. You can remove it from the list. And so the item at the top is not scale at all. In fact, you can make it to scale on the opposite side. So it grows a little bit above. Okay. Now the last part, and we're getting close to the end, is can we resize all this based on an attractor? So an attractor is a point that we place in space. And so this point, I'm going to put it on the surface of the, and then relative to the, it could be a point or it could be a line. I'm actually going to do the line. And what that means is that a line on the surface is going to act as an attractor, and the distance between the line and the insertion point for each of the windows is going to get measured, and that's going to give me a ratio that's going to drive the opening of the window. And so we'll use Launchbox to do that. Okay, did it work, Cass? Are you still processing? Okay, the other alternative, while that finishes, I mean, I'm gonna add. You don't have to do this, but if I want to go, and we were talking about making this have this a material, right, or a thickness. If I edit this family, and then I select this surface, and then I give it a form, you see how it becomes solid? But then if I select this, I could say, okay, this is the thickness of that is going to be 6 inches or 4 inches. There you go. Now you load this into the project, and again, I'm not going to do it because it's going to reprocess all of it. And the other thing you can do, it's I'm going to undo all this, is you can make a version of this with a glass panel. And then, sorry, material, glass. And then I'm gonna save it as. You don't have to do this. I'm just doing it as an option. Glass panel. I'm gonna load this into the window unit and make the glass snap to the interior. 1, 2, 3, 4. And that way, you know, when I load this, it has it doesn't look like it's completely open. Do it on your own. All right, are you with me, Cass? Now? Still processing? Okay, well, you have to watch the recording. I'm going to close my families that I don't need. All I need in the background is the tower. Make sure you close the rest of the files. Okay, the last part is to add the attractor. And so for the attractor, look for the word attractor. And you can right-click and look attractor. And there's a Launchbox attractor. That's what you want. So attractor is asking for the attractor geometry. The attractor geometry can be a point or a line. The target, it's a point as well. The minimum value, it's 0.1, and the maximum value is going to be 0.25. Okay. All right, but here I have the list of all my adapted components, right? And remember the parameter of the property is called R, right? So in Dynamo, I can change that. I can access that parameter using a node called element parameters by name. So it's called element dot parameter parameter name, parameter set, parameter, yeah, parameter by name. That's parameter by name. So if you just search parameter by name, is set parameter by name. So what this node does, it's search for a specific parameter of the adaptive components. The elements are the adaptive components. So I'm going to switch this. The parameter name are, so text inside a code block needs to be in quotation marks. Yeah, otherwise it becomes a number and trying to, and it needs to match exactly. So if you make this R, capital R, make sure you fix it. It needs to match exactly the same way you did it in the project. So this is the parameter name. And then here are the values. And I don't have those values yet. The values are going to come from the lunchbox. So double check that the parameter name matches in capital letters the way you created your family here. I call it R. You need to make sure it matches. All right. Each adaptive component has an insertion point, and that's what I'm going to use to calculate the attractor. So you hit right click and then search for, I think it's called location. Get location. Get view, get name, get latitude, get room location, set get location. I think it's this called get location. Element.get location. And if you connect the adaptive components into the get location and you hit run, this is going to be the insertion point of every adaptive point. And you see I have 600 points. So if you look at the lunchbox node, where does the location go? In the target, exactly. Because remember, what this is doing is calculating the distance between the attractor and the target. And the target is each of the insertion points. So this goes into targets. Minimum and maximum, that's the value of the R value. So in a code block, I'm going to make it 0.1 as my minimum and 0.45 as the maximum. Yeah, so this is the minimum here and this is the maximum here. So the farther is from the point, the smaller is going to get the hole. So it's going to be 45. And then the attractor, like I say, it could be a point. I could just create an XYZ, or I can create a line, and the line it's an ISO line. An ISO line it's a line over a surface. So if you right click and search for ISO line, it's called get ISO line. get isoline. And the surface is actually not the panels, it's the actual surface. So we need to look for the, remember the loft? So we need to find the loft, which is a little bit in the back. Where is my loft? I have the nerve surface. If you have the loft, then connect it to the loft. If you're using circles, use the nerve surface. The nerve surface all the way to the isoline. The ISO direction is, you want the line to be vertical or do you want it to be horizontal? Vertical, it's 1. The default value is 0, you see that? So let's put this 1 here. 1 is going to make it vertical line. And then the parameter, it's where in the surface you want this to happen. 0 is at the start of the surface. 0.5 is at the middle of the surface. 1 is at the end. I'm just going to leave the default. So if you run this, which I just did, you're going to see that a line is going to appear in the vertical direction of this surface. And I need to find it. There it is. You see that blue line? That is the ISO line. And that ISO line, where does it get plugged? Into the attractor. Okay. Okay, so this is going to give me a set of values from 0.1 to 0.45, right? And the very, very last step is to plug the values coming out of, why don't we run it first? Let's run it first. And nothing. You have the lunchbox filled out? Okay, so curve is the attractor. So notice how the lunchbox has, in my case, I had 600 elements. I don't know how much you're going to have. But these need to match the number of adaptive components. I have 600 adaptive components. And I have 600 values of R. And these are, where does it go? Into the set parameter by name. It goes into value. Again, save it, because this is going to take time. Run it, and let's wait. In Dynamo. You will see that effect in Dynamo. And what this is going to be, each of them is going to have a separate opening. The ones that are closer to the ISO line are going to have the maximum aperture. The ones on the opposite side are going to have a smaller aperture. And by the way, you don't have to have a single line here. Like in this attractor, I only have one curve, right? But I can have a curve or a point. And so what it's going to do is it's going to do the math.
So you can have like several points.
I can have several curves.
So you can just attach a list of curves or points into the attractor.
Correct. If you hover over here, you're going to see that it says it's accepting a list of lists.
So you can do that actually like random seed points.
The parameter is set by parameter. So that's why. So we need to make it at least in parameter. You see how this is added the lower default? We need to make this parameter at least in parameter. So every window is going to have a separate value. So Is finished. Good luck. Is it blue?
Oh, yeah, and then you can put more like
Okay, look at mine. It's pretty obvious too. It's really thin on one side. And what I was saying is that you can make it one vertical and one horizontal line, and then you're going to have a bidirectional.
and then if you have like secret towers, so you will have more like distance between the lines. Mine is thinner, so the openings are bigger. It's close.
Correct. Okay, so save this file and take it with you, and then customize it as you please. You can, it'll work. It's the processing.
No, it's done.
Okay. Can you see? Can I see the record? Very good. There's one there. I can. The thing is that this, when this gets preloaded, it needs to get refreshed. Right. Okay, I want to go over the sheets very quickly so that you can create your sheets. So if you don't mind staying 5 minutes after, is that okay? Okay, I'm gonna exit Revit here. And open it again. I want to go over quickly about how to create a sheet, and it's going to be so quick.
So we will close the Dynamo.
Yeah, we don't need that. Save that DYN. Make sure you take it home, unless you're going to work here. Yeah, take it home. Take also the, if you don't, take with you the adaptive points as well. All right, so when we create sheets, so this demo, just go open the sample files. And go into the, do you see the ARC link model? Open it. This project already have some sheets there. And we're going to, if you see there's a floor plan sheet, and there's one called sections. And in addition, there are some renderings. You see there's some renderings here. So to add images into a project, I have to create first a drafting view. Remember, a drafting view, it's a white piece of paper. So you go to View tab, and then create a drafting view. I think it's this icon. It's And I'm going to call this image 1. This is like a white piece of paper. It doesn't contain any connection into the view. And I'm going to add an image. So to add images, you go to the Insert tab and go to the Manage Image. And from here, you're going to do Add. And here you're going to navigate to the screenshots you've saved from Dynamo. I think I have a lot of pictures in my pictures. I go to my computer. Then I go to pictures. I don't know if you have pictures there. I have one that is called Scan. I don't know what even that is. Okay, like here's an image, a computer image. This is an image of my screenshot. And so I click OK here. And this is just to add the image into the system. And then to place an image, you just click Image. And then place it somewhere there in the middle. When you measure the image, this is the printed size. Actually, it depends on the resolution, right? So my resolution, these are really high res because I took this with my cell phone, and this is 37 feet. So what I recommend to you is to change this to 1:1. Change the scale to 1:1. And when you measure this, think about the printed size of your image and then scale it that way. So you select the image, then you use the scale button, or you can just grab one of the handles on the right and scale it down. And then again, you measure it. This needs to measure about 4 inches. If I want this to be 4 inches, then it needs to measure 4 inches. And this is still a foot, so scale it until you have the size that you want to. Oh, so when you scale, you can do numerical here, and you can do 0.1, or you can do graphical, and you graphical. There it is. Okay, so these end up measuring, let's say, this is 2 inches. That's too small. So the sheet is 30 by 42, so you need to design it. All right, now that you have the image in the right size, you close it. And then create a new sheet. Just go View, New Sheet. What is this? This sheet with an asterisk. And this is going to ask you for a title block. You can choose to modify the title block as well. Like you see, this title block is really ugly. I don't like it. If you edit the family and save the family as a new family, you can remove everything. What we want is not a construction documentation one. We want something that it's designed. Right? So open this, save it as a different file, load it. And when you load it, then you're going to have the ability to swap it or change it. Okay, just for time's sake, I'm going to use one of this. So I go ahead and View, create a new sheet. I select the 30 by 42. 30 by 42 already have the right size, so all you need to do is change it. And then you drag and drop from the drafting image. You drag it and drop it, and that's the image at 4 inches. Now, if you don't want these to appear, in the properties of the view, change the viewport to. This is what we'll do. You select the viewport, edit the type, duplicate it, and say do not show the title, and then that's going to be gone. And then you're going to modify this to remove it, and you drag and drop the reference view, and you see that's very small. Oh, you know, the scale has to be 1:1. If global open this, yeah. And this scale needs to be 12 equal 1. Very close. You go back to the type 2. Now, to get rid of the title, that's what I want to explain. I'm going to repeat this again because the title is very good for construction documentation. I don't want you to use this. So you select the viewport, edit the type, duplicate, and call it viewport graphic. Then you disable the show title, change it to no, and you click OK. Now the title is not there anymore. And now you just have the image. And then you start making your composition there. Does that make sense? And again, look at the example I gave you. You need to add a little text at the top that have your title of your project and who are you and what's the class. And again, if you come here at 7 next, let's do the official start at 7:30. And if you need more time printing, just let me know. And then next Wednesday, I can be available either Monday or Tuesday for web support. If you need web support, shoot me an email. You have my email, right? crearchitecture@gmail.com. And I will schedule a one-on-one critique, and I can give you tips as well. Just have a place that you can connect with the internet, and I'll send you the invite. If you don't need my help, well, I'm going to assume that you know what you're doing. And then next Wednesday, we will put this on a board, and we'll have each speak maybe for 5 minutes. And that's going to be it. Right? Okay. So, any question about the class, about the script? All right. Hope you have fun doing this. But again, this was supposed to be intro to Revit. I think we went overboard. We did really advanced, so I hope you learned. All right, so good luck. I know you guys are probably busy with all the rest of the classes, so thanks for your effort.